from Mizuho Research and Technologies Limited, we have Mr. Kohei Oshio, and from HSBC, Mekena, Metcalf, and from Mitsubishi UFJ Financial Group, we have Jumpei, Kato, and from Sumitomo Mitsui Trust Bank, we have Naoki, Mitsuda, and the moderator is a Professor Yohichi Suzuki from Keio University.
Thank you very much. This is Suzuki, Quantum Computing Center representing Keio University. Mitsuda-san, Kato-san, Oshio-san, they were involved in the joint research at Keio University. So that because of those associations, I was asked to serve as the moderator for this session. Because before we begin, we would like to ask each panelist to introduce himself or herself. Mitsuda-san, would you please start? Mitsui, Sumitomo, Trust and Banking. I am Mitsuda. Mitsubishi UFJ Financial Group, Mizuho Finance Group. Together with those companies, I represent the Japanese financial service provider. So there's independent trust and banking. So the asset management and corporate business pension annuity management. So we are involved in the asset management. I was in charge of the managing the pension annuity for the corporate pensions, and then I was assigned to digital transformation for this company, and then I was dispatched as the joint researcher with the Keio University after 2.5 years. This past March, I came back to the previous organization, the Trust and Banking. I'm in charge of data science and improving the efficiency of the operation. At the same time, I'm promoting the quantum computing project. Thank you. Thank you, Mitsuda-san. Next person, Kato-san, would you please introduce yourself? MUFJ, I am Kato, Mitsubishi UFJ Financial Group. This is a commercial bank as well as a trust and banking company and the securities service the company. So this is a global financial service company. So Mitsubishi UFJ, the digital transformation is one of the most important management pillars. Digital transformation, this is a major business transformation that is felt by corporate clients. Quantum computing will also contribute to the business transformation. So that is the reason why we're involved in quantum computing. We began the research of quantum computing in 2018 at Keio University. IBM Quantum Computing, the network, our company was represented at this IBM initiative. So we dispatched researchers at Keio University, and we continued joint collaboration, joint innovation initiative. We were involved in and we have been exploring those projects, SKI, and myself, Kato, of Mitsubishi UFJ. Mitsubishi UFJ Bank. I'm associated with the system development. I'm the expert credit risk and numerical computation of the credit risk computation. I'm very much interested in the application development. Thank you very much. Mekena-san, please, would you?
Hi, my name is Mekena. I am a quantum computing research scientist for HSBC Global. HSBC is one of the largest banks operating in 64 countries with over 240,000 people. And our quantum computing program is a global initiative. So last year, we initiated our quantum computing program within HSBC across several countries around the globe, myself based in the US. And we hired quantum computing research scientists like myself externally and brought them in to be able to work with business units to be able to do discovery around how we could use quantum computing for applications around the bank. I myself, we sit in innovation and ventures within HSBC Global in digital business services. And within that, our HSBC lab team focuses on disruptive technologies, including blockchain, digital assets, generative AI, and of course, quantum computing. And I'm excited to be here to talk to you about what we're doing.
はい、 りがとうございます。
Thank you. Representing Mizuho Research Technologies, I'm Oshio. At Mizuho, as part of Mizuho Financial Group, this is one of the entities of Mizuho Financial Group. So we are the research arm of Mizuho Bank Group, Financial Group. So this is a research and technology arm of Mizuho Financial Group. I myself, Oshio, I was involved in the leading edge technology, research, development, and analysis. Quantum research, I have been engaged in the quantum research since last year. I'm working at the financial application of quantum computing at the Keio University. So I'm participating in the joint research together with the Keio University. Thank you, Oshio-san. Representing the academic perspective, especially the financial institutions, what kind of R&D structure organization is going on? What about the internal organizational structure? Would you please elaborate on this? Oshio-san, would you please enlighten me on this? What is the internal structure? Mizuho Research and Technology, part of Mizuho, the financial group. So this is a dedicated research functionality and I'm a researcher. So I'm leading the R&D for Mizuho Group. But Mizuho Group as a whole, financial group as a whole, in the area of advanced technologies such as quantum computing, the Mizuho Group as a whole is engaged. ChatGPT, the interactive the technologies incorporating the business. So the management is interested in advanced technology, including quantum computing. So there is a promotional atmosphere for the entire management of Mizuho. So one such sign is that the former chairman, Mr. Sato of the Mizuho Financial Group, academia and industrial quality, the quantity innovation, the council, QII, he was a chairman, serving as a chairman for the QII, our former chairman. Last year, sustainable quality, the quantity, quantum, from the Mizuho, the financial group, top executive was represented as a deputy. So not only the research and technology arm of Mizuho, but the Mizuho Financial Group as a whole is proactively engaged in the R&D. Mitsuda-san, how about your organization? So at Mitsui, trust and banking, digital transformation is a major management challenge. That is our awareness. We have a number of group organizations. Each group company is pursuing digital transformation. That is not efficient. But each group company has a sizable organization. So to enable the dynamic, agile movement, so at Mitsui, Sumitomo, and Trust, we have established 2021 April trust-based company that is a dedicated subsidiary to promote the digital transformation. So there is a dedicated subsidiary is in the area of digital asset management, blockchain, quantum computing, those leading edge technology. So this subsidiary is promoting those leading edge technology. For quantum computing, as I mentioned earlier, the Quantum Computing Center, we have dispatched researchers to Keio University. So our bank associates who have studied at Keio University comes back to Mitsui Trust and Banking and promotes the quantum the initiatives. I was the first generation dispatched to the Keio University as a researcher. So the experts who have been dispatched to the Keio University is not so many. The financial sector in the utilization of the quantum technology, what is the expectation you entertained for the quantum technology? Although this is a financial session, I myself, representing Mizuho, Mr. Oshio, this is not just restricted to the narrow sense of the financial service, but we should look at the much broader perspective. In the morning session, at the Boston Consulting Group, expert was talking about maybe this technology could be applied to areas that have never considered to have any proximity with the quantum computing, but there is a possibility. Mizuho Financial Group, back in 2019, we have the 5-year management plan, transformation to next generation financial services and technologies. Not only the conventional financial services, but encompassing also non-financial services to apply those new technologies. So this is the focus of our direction, not just the traditional financial services per se, but much broader. The talent management and the IT, transportation, we would like to apply the quantum computing to be applied to those broader areas. Utilization of quantum computing technology have talked about. Kato-san, what about you?
So he talked about looking at the possibilities broadly, but what about your case? Okay, from my perspective, I'd like to give you an overview of the example applications in financial service. This was talked about in the morning, but there are 4 patterns or types of applications: simulation, optimization, machine learning, and cryptography. These are the 4 major areas we are interested in. And briefly, let me give a financial example in each area. Regarding simulation, economic indicators or stock prices, a forecast, because in financial field we calculate risk or we price derivatives based on forecasting those indicators. And this is an area where there's a need for computing. And optimization is more intuitive to understand. Portfolio optimization, where you can get the biggest return by investing on certain assets you can use in this area. And machine learning have a whole lot of variations based on the application and data set you have. But for simulation, for example, you could use GAM to control the quantum state for simulation, or algorithm trading strategy is another application. And in the compliance area, anomaly detection or detection of fraudulent use of credit cards or identification of financial crimes are also potential applications. And regarding cryptography, in the financial industry, cybersecurity is a matter of high interest because the conventional cryptography can be solved. And this is something we are watching. And in terms of communication, research activities are also underway. Thank you very much. So various applications, but based on the current state, people mentioned the NISC earlier, but how do you see the current state, Oshio-san? You mean the current state of the quantum computing R&D? Yes. Okay. At Mizuho Financial Group, since 2018, we have joined the Quantum Computing Research Center of Keio University, where full-scale research activities are conducted. And I was not part of it, but back then, the actual quantum computer had only a handful of quantum bits and managed to do only very simple calculations back then. But recently, quantum computers have hundreds of qubits, and maybe in 1 or 2 years, thousands of qubits will be realized. So the performance of actual computers are improving significantly. That's how I feel. And as with our research activities, quantum computing applications, when you think about the actual applications, you cannot know until you actually run it. Even if the effectiveness is proved and demonstrated theoretically, you will not know until you actually run it whether it will work or not. Or sometimes something that is not proven theoretically can work out if you actually run it and demonstrates better results than classical computing. That is also another possibility. So we are using actual computing, quantum computing machines. We would like to use actual quantum machines to see and evaluate those situations. Thank you very much. Now, specifically, we'd like to discuss more specific topics. So what kind of topics are you working on in R&D activities, and what are the important topics for you? Mekena-san, could you take up?
So we have a good-sized team, and when we kind of all started last year, we were going through and assessing what we were actually going to look at. And our research program was largely driven by the needs of the business. And so prior to joining, our leadership went and was able to kind of consolidate a list of use cases, potential use cases, from different areas of the business all across the world, ranging from wealth and personal banking, risk and compliance, markets and security services. And we went through that and we started assessing whether, like, what would be a good use case to build the foundation of our program upon. And so there's 5 researchers, so we selected 5 use cases, one for each of us. And they were prioritized by what could be done in the near term and what was more near term applicable. So largely in our group, we don't focus so much on fault-tolerant quantum algorithms, but we look at the quantum technology that we have today, and we want to see what we are able to do with it. And I think what Oshio was talking about is actually really relevant, is we can read papers and see what types of algorithms are out there, but it really isn't until we start assessing them in the real world, using real data, working with the business and getting feedback and doing benchmarks against what they're actually using to see it, like how applicable it would actually be. And this is kind of the approach that I have taken with my research. I work mainly in risk and compliance, looking at quantum machine learning algorithms for fraud detection and anti-money laundering. And one of the big successes that we had in collaboration with IBM was being able to see how quantum machine learning actually worked using real customer data and benchmarking against the best in class that they were using in production. And I think it's also important to say is that machine learning itself is rather new to the financial services industry because there's a lot of risks associated with using machine learning models. And so there's certain criterion that we look for: efficiency, how well it actually does, how well do these algorithms scale, as well as interpretability. So sometimes you might see a really good machine learning algorithm out there, but it's a black box solution, and that's not something that we can actually use. So when we approached quantum machine learning for fraud specifically, we looked at these 3 criteria and tried to find the best quantum algorithm to use that would be something that the business would actually find valuable in the near term. Similarly, we also look with Fujitsu at simulated annealing and how we can use these annealing technologies to be able to clean up our portfolios when it comes to environmental and societal impacts. And we have, working with Fujitsu, we've put together an optimization problem. That's something that we can actually use in production using these FPGA solutions. And something that we're really excited about, that again is near term, but is probably more on the exploratory side, is the work that we've done with British Telecom, joining the BT Quantum, London Quantum Network. And we've been able to install QKD devices on-prem at HSBC headquarters in London, and we'll begin carrying out security tests in the next year.
Well, very specific information you shared. Thank you very much. Now, Kato-san, what about you? Okay, from me, as I said, I'd like to focus on simulation side. So about working on issues that have actual business needs. And when you think of simulation, it can be simulation of stock prices. In the future, you have to run calculation every day. And one thing we use is Monte Carlo simulation. You may feel this. Monte Carlo simulation, models are getting quite complicated and difficult equations are getting used. And it is difficult to it is difficult to do the simulation, but Monte Carlo allows you to do the simulation using a brute force, and this is very came in handy. But the computational cost is very high. In bank operations, you do overnight batch and run calculation, and there are hundreds of probability variances, and you have to run this calculation every day. Very resource-consuming calculation. And then, if you look at quantum technology, high speed-up algorithm have been proposed, and theoretically, we know that it is possible to do this calculation using quantum. Then, as Oshio-san said, if you want to apply that algorithm in reality, you cannot run it on existing actual machine. So, as Keio team, we have tried to improve it so that it can run on the actual existing computer. For example, exploring a way to accommodate some noise. We have published certain papers in that area. Okay, thank you very much. Well, short term or long term, you speak about this time frame, but for the short term, what is important? Oshio-san, please.
Short-term research in the short-term, immediate future, readily useful NISC or FTQC machine. So you would like to expand the kind of the computation task that can be run in the short term. I think that's the common awareness of all of you. At yesterday's session as well, today's session, the hardware providers talk about error correction, error mitigation, and data suppression. To reduce the error from the hardware approach, that is the approach of the hardware, but from the algorithm, improvement should lead to make the system or the algorithm tolerant against the errors or the fault tolerance. And we have to increase the number of applications, and currently the kind of applications, the number of applications, but we should pay attention to other algorithms, not just the computation time and memory resources and sampling superiority. We should expand the range of applications, looking at some other characterization. Mitsuda-san. What about you, Mitsuda-san? As Oshio-san said, my point will be similar to Oshio-san. In the short term, the practical use case or the concept proving, and those are important. And in financial areas, the application and algorithm, there are a number of applications, algorithms being proposed, but not so many of them can be utilized in the real financial business. There are not so many of them around there which can be utilized in the real business. The size could be, even the size could be small. If certain algorithm could be robust enough to be utilized for the financial real business, then a lot of enterprises will be interested, and the R&D will be accelerated. From another point of view, talent development, that is also important. Developing talents in the financial industry. There are not so many experts around who have knowledge about the quantum, but the quantum experts, they do not know so much about the financial business. So the financial business, the real business, and the quantum, so in both worlds, the experts should be nurtured and developed. So to enable the development of the quantum technology, the quantum experts and financial experts should be nurtured and developed. So those are the short-term requirements. For the FTQC, if the FTQC becomes widely available, for the real application, what could be the problems? What could be the possible problems? Not only the hardware or algorithm issues, there could be the international collaboration and standardization, and regulations, and legal framework will also become important. Mekena-san, what about you? What is your opinion?
A couple of issues that have come up that I've noticed since I've joined HSBC. And I myself, I'm learning about financial services. I came from quantum information science. So it's interesting to see these things appear. So for instance, like with Monte Carlo simulation, we might want to be able to use these fault-tolerant quantum computers to be able to do these advanced techniques. But there's some processes that are necessary in order to bring models to life within financial services. And they have a very rigorous model validation process that you need to be able to go through. So you can imagine if you're working with a client and you're going to use a quantum computer, a fault-tolerant quantum computer, to make a decision about a trade based off of a Monte Carlo simulation, and something goes wrong, and it comes down to the model, you're going to be at a really large risk as an organization. And so I think that process, while it's well established for classical techniques, it's going to be very difficult to set the precedent and explain to regulators, explain to the folks within risk who validate these models exactly what quantum is and how it works. And there's also another side to that coin, which is an active area of research in quantum computing. And it would be interesting to see this more heavily tied to financial services, which is the verification and validation of outputs from a quantum computer, where let's say you get a result from a quantum computer, but you need to make sure that is in fact the correct answer. And those are actually very difficult protocols, as we know, from a computer science perspective. And to be able to make those not just like purely theoretical, but how do we bring those to life? I think that's going to be a necessary component in order to actually start to use a fault-tolerant quantum computer in production. The other thing that has come to light since I've started, and this is even for near term, is quantum computers are extremely expensive, and they're very difficult to get access to. And so we work through these cloud-based services, Amazon and IBM, to be able to connect to the quantum computers. And cloud is actually a very touchy topic in finance. There's a lot of questions about data privacy across international borders. For instance, I know here you have a quantum computer in Japan. You have quantum computers in the US. But sending data to the quantum computer is a non-trivial task. So, right now we're left with using public data or synthetic data to actually send to quantum computers because the precedent is not set on how we would actually get real valuable information onto these machines. There's also issues. So we have, for instance, these cloud-based services, and we have smaller quantum computing companies who are building these technologies, trapped ions and cold atoms, superconducting qubits, and this is considered like a fourth party. And so you might have an ability to send data between Amazon and HSBC, for instance, but you don't have the ability to send it to the other provider where the quantum computer sits. And so if we did see something happen with fault-tolerant quantum computers tomorrow, I think it would be years until we would actually be able to get real valuable data onto those quantum computers. And I think it's important to start setting the groundwork now to be able to either bring these devices on-prem, like we've been doing with the QKD system, or start, through successful use cases, saying, okay, it's important to start in getting these wheels moving so that we can actually be able to send valuable data to the quantum computers in the future.
なるほど。なかなかそうですね。いろいろ。
So if you think about those minute, detailed areas, there are potential issues, as you have indicated, Kato-san. As Mekena-san said, so the validation is the area I'm quite interested, strongly interested, because I'm involved in the real the banking business. Validation and verification in financial services. You run the calculation based upon hypothesis to be reflected over the financial basis and make the management decisions. And so you make the models. And when you design a model, the validation should be done by a third party, independent third party. So this is the principles of the financial business. Validation should be done by, could be the internal validator or the audit or the validator, external auditor, a validator, the regulator who perform the validation, external or internal. So what is right to be verified? That was the process of verifying. The items to be verified has been defined over the years to the experiences, for instance, in the regulation. Well, what is the stability of the data that is being generated? What are the variations and differences and objectives? The degree of importance, and depending on degree of importance, the priority or the order of the validation vary. Could this be readily applied to quantum computing? I have to put a big question mark. The validation, the verification metric that I've seen in the past, whether the verification metrics in the past, is this really applicable to the quantum computing? Maybe you need a metrics for the validation that is unique to quantum computing practice. So you have to make the preparation to make this business ready. So this is the area, and that requires standardization in the financial industries as a whole. And we have to reach an agreement across the financial service industry. Thank you.
Thank you. So, of course, there will be a whole lot of challenges, but for a adoption of quantum computing in the wider society, what do you expect from the national government? Well, what I expect from the central national governments, there are many of them. For example, the developing researchers or financial assistants are among them. But there's one thing as a business to ask regarding the performance of quantum computing. Standardization or this creating a standard criteria for assessing the performance, because quantum technology is a quite new technology. So in terms of the speed or accuracy of quantum computers, there is no unified criteria or standards to assess them, or the benchmark for a quantum computing software as well. Those standards are missing. I personally feel that way. So I hope that central governments can work to create standards, getting input from the private sector businesses. I'd like them to take the initiative to drive this standardization, validation, and laws and regulation. I think your comment is tied to that area, and yes, we do have expectations in that area. Now, so one last thing, looking into the future, what kind of initiatives would you like to work on going forward? Mekena, could you start?
Yeah, I think that there is a tremendous throughput issue. So we have a small amount of trained quantum researchers and FS trying to forge the path for how we actually use quantum technology in financial services. It's a tremendously big task. And what's been super unclear, and I think we're still trying to figure out, is how, the only way to increase throughput is to enable other people within the business who, actively have day jobs, trading or running, data analytics models, to actively engage in quantum computing and start being able to do some of the legwork themselves. And, it was thought that maybe education programs would be a really good mechanism for this, because there is a curiosity, but turning that curiosity into action, where you have, rather than always funneling through us, but you have business lines being able to interact with quantum computing companies, almost not, maybe in some sense independently, to increase the throughput, I think is really important. And so we're working on trying to kind of foster a culture that will enable this, to increase the bandwidth of what we can do in quantum computing. And I think it's largely going to be driven by the results that we see. as we start seeing interesting results that could potentially impact business lines, I think that passive curiosity will start to turn into more active work and research. And so that's, I think, what we need to see, not just within financial services, but across industry as a whole, rather than, having a few quantum scientists carrying the mantle for Fortune 50 companies.
はい、ありがとうございます。なかなか
Thank you very much. Yes, and if we produce a good result, then that will motivate others. So there's a hefty responsibility on our shoulders. But Mitsuda-san, what do you think? Okay. So as I said in the very beginning, since 2020, I have been in Keio University researching on quantum computing, and what I was researching in there was a basic research, basic technology required for quantum computing. But when I came back to my company, instead of the basic researches, I was expected to do researches which are already applicable to actual business. News media took up quantum computing as topics, and the business units which do actual financial operations became interested in using quantum computing to be used for their own operations. So we received those ideas or proposals from business units, and with that, we would like to create an applicable applications that can be really work in their business context. Okay, thank you very much. And one final thing, because we have some more time, so let me throw in one more question. The quantum computing initiatives in Japan, Mekena, how do you see what we do in Japan about quantum computing?
I'm really impressed. When I met my fellow panelists preparing for this, finding that they have been collaborating together within a consortium at Keio on fundamental research across banks was extremely impressive. I feel, what we've been doing in the US and in Europe is we work independently. We don't collaborate across banks. And I think that ability to have a cohort that you can rely on and exchange ideas with across corporations is just truly impressive. And in addition, something that's kind of come to light and I'm very curious about is I didn't realize the importance of hardware access. I believe it's something that I've taken for granted over the course of my research, and seeing how valuable that access to hardware is through the Keio, like IBM Quantum, through the Riken Institute, so that you can actually play with it and get your hands dirty. And I'd hope that we can be able to support further technology development in hardware, not just in superconducting qubits, but in other technology lines like trapped ions and cold atoms to foster the quantum computing program here in Japan.
はい、ありがとうございます。
Thank you very much. From an object point of view, because we are chatting with each other always, and we sometimes lack input from external parties, and in that sense your comments were really precious. Thank you very much.